So this is exam 2, lesson 3 video. We're going to look at simplifying fractions, look at equivalent fractions, and then determining area of shapes that are regular and irregular. So objectives, we'll look at multiplying by 1 in order to determine an equivalent fraction, an expression using different denominators. Then we'll look at simplifying fraction notation and testing for equivalence, and then we'll solve problems using multiplying with use of area. So when we're talking about multiply by 1, think about the identity property of multiplication. So a being a variable equals a times 1, we're going to get a. So if we took 4, and multiplied it by 1, we're going to get 4. If 4 was representing as a, we would get a. So let's look at some of these examples. If we take 1/4 and we want to multiply it by 3 divided by 3, well, that 3 divided by 3 represents 1. So we're really not changing the value of 1. It's 1/4 times 1, which will still be 1/4. Now, if we look at an area model here, and I want to create see here, let me erase that. I want to create fourths, then I would want to identify a fourth. And so this being split into fourths, and then I have, I want to create 3/3. So if let's take and split the horizontal side into thirds, then what we can see is we've just created is a third. I'm showing 3/3, but I also want split this into thirds, and I already highlighted 1/4. So I'm creating 3 of the total of 12. So how do we get 3/12 out of this? Is we multiply 1 by 3 and get 3, and 4 by 3 and we get 12. So we have increased the size of fourths into twelfths. So we multiplied 4 by 3 and 3 by 4 to get that denominator of 12. So again, if I want 1/2 and I want to multiply by 8 divided by 8, which is my n divided by, it's going to give me 8/16. So I still get 1/2. It's just equivalent, and 8/16 is equivalent to 1/2. So I'm creating, instead of thirds now, I'm going to create 15ths. So 2/3 is equivalent, when I multiply by 5 divided by 5, I'm going to get 2 times 5, which is 10, 3 times 5, which is 15. I'll get 10/15. And then with 4/3 multiplied by 5, well, 4 times 5, that would be 20, and 3 times 5 would be 15. So again, we are creating equivalent fractions by multiplying by a n divided by n, which is different for each of these. 3 divided by 3, 8 divided by 8, 5 divided by 5, 5 divided by 5. So when we started out with fourths, to multiply by 3 divided by 3, we ended up with twelfths. We started out with halves, multiplied by n divided by n, or 8 divided by 8, we end up with 16ths. Started out with thirds, multiplied by 5, now we ended up with 15ths. Started out with thirds, multiplied by 5, we end up with 15ths. So let's look at a different approach where we've got 2/5, and I want to know what I'm going to multiply by to get negative 35 in the denominator, well, 5 times something to get negative 35, well, that has to be negative 7. Well, this has to be negative 7. So that would be negative 14 divided by negative 35, which is the same as 14 35ths. So 2/5 is equivalent to 14 35ths. Let's take 3/4, and what would we multiply that n divided by n by to get us a denominator of negative 24? And we also need to figure out what that numerator would be. So 4 times what would it give us negative 24? Well, that has to be negative 6. So this has to be negative 6 because negative 6 divided by negative 6 is 1. I don't want to change the value of 3/4. So now 3 times negative 6 would be negative 18, which would be 18 24ths. So simplifying the fractions, remember we can think about, let's try to factor the numerator and the denominator. Look for common factors and use those common factors to remove a factor that is equal to 1. You are thinking about this n divided by n. So if you take 6/8, you notice in the explanation here, it's saying, well, what's 3? This would be 3 times 2 and 4 times 2. So if you divide out those factors, common factors, what are you left with? Well, you're left with 3/4, which is the same as 6/8. And that, remember that 2 divided by 2 is your n divided by n, which is 1. So if we take negative 8/20 and we try to simplify that, that would be negative 2 and 4 and 5 and 4. So we can see there's your n divided by n, which would divide, so it becomes 1. And so you're left with your equivalent fraction of negative 2/5. If you take 14 24ths, well, this would be 7 and 2 and 12 and 2. 7's prime. 7 will not divide 12. And here it looks like there's my n divided by n, which will divide out, which leaves us with 7/12 as a result. If I go with negative 15/10, let's have negative 5 and 3 and 5 and 2. Well, it looks like I'm going to need to place that negative with the 3 because my n divided by n needs to be 1. And so that will divide out, and that leaves me with negative 3/2. That would be the same as negative 15/10. And then negative 50 divided by 30 is the same as negative 5 times 10 and 3 times 10, which is sometimes where you'll see, sometimes you can see the zeros, and it's like you're dividing out the zeros. Well, there's a reason you're doing that, is because that's that n divided by n. That's that 10 divided by 10, leaving you with the negative 5/3. We can also compare fractions by using cross products. So this 6 times 5, which is 30, is equal to this 10 times 3, which is also 30, which means that these are equivalent. So let's say that we found a common denominator of 50. I'm wanting to know, are these equivalent? Well, that would mean that I would multiply 5 times 10 and 3 times 10, because I need to have that n divided by n, and this would be 5 multiplied by 5 divided by 5. So notice that this would end up giving us 30 50ths and 30 50ths, which would be equivalent. Now, if you also look, what did we multiply the 3/5 by to get a common denominator? It was 10/10. But notice what you multiplied 3 by. You multiplied 3 by 10. Notice what you, over here, what did you multiply 6 by? You multiply 6 by 5 to get that common denominator of 10. So multiplying that 6 by 5 and that 3 by 10, notice that represents how you are using cross products. So negative 10/15. I just want to know if they're equivalent. And so 15 times 8, that's 80, and 40, that's 120. And then negative 10 times negative 12, negative times negative is a positive, that's 120, and so those are equivalent fractions. Here, if you look at 2 times 9, you're going to get 18, and 6 times 3, you're going to get 18. So those are also equivalent fractions. And then if you look at 2 times 20, which would be 40, and then 3 times 14, that would be 30, and 12, that would be 42, and these are not equivalent. And then 6 times 8 and 16 times 3, 6 times 8 is 48, 16 times 3 is 48, so this is checked. So these are, this one's not, and those other two would be equivalent fractions. So next we want to look at solving problems multiplying using area. So Charlie's Landscaping uses 2/3 pounds of peat moss when planting a rose bush. So that would be 2/3, think about 2/3 per one bush. And he's just trying to figure out how many he needs for 21 bushes. So you could use a proportion here. This would be 2/3 times 21 equals X. And then over here, you would multiply your fractions, remember? So that's 21 times 2. So that's 42 divided by 3 is equal to X. And 42 divided by 3, it's 4 plus 2 is 6, so we do know that 3 will divide it, and it'll divide 14 times. So 14 is equal to X. So he will need 14 pounds of peat moss to plant 21 rose bushes. Simplifying fractions by dividing out the the factors is, so looking at this method here, so we've got 2/3 times 9/4. We can certainly use commutative property and switch the denominators to make this 4 times 3. And then we would see, well, 3 will divide 9 3 times, 2 will divide 4 2 times, so you're left with 3 in the numerator, 2 in the denominator. Now, you could think about, well, 2 times 9 is 18, 3 times 4 is 12, and then try to simplify from there. That would be another approach. You're still going to get 3 halves. Take 6/7 times negative 5/3. We could say, well, we can multiply and say, well, that's negative 30 and 21. So we could look at saying, okay, well, that's going to be -3 and 10. And let's do this. Let's make the -3 positive and the 10 negative. So we can see our n divided by n, and we would be left with -10/7, which would be the same. And so let's look at it. If we had 6/7 times -5/3, we could say, well, 3 will divide 6 2 times. So then we would say 2 times -5 would be -10, and this 7 in the denominator times 1 would be 7. So you get -10/7, which is what we saw over here. And then let's look at, what if we had 32 times 7/8? Well, I could certainly multiply 32 times 7 and place that result over 8. So that would be 210 and 14, so 224. And then I could divide, so 8 will divide 224 28 times. Okay. Or I could look at, well, 8 will divide 32 4 times. So what's 4 times 7? You get 28. So you're still going to get the same thing. It might be easier to look at how these will divide diagonally, or how they might, in another approach, how they might divide vertically. 3 will divide 9, 2 will divide 4, in that manner. Okay, let's move on to finding area. And if you're going to find the area of a rectangle, of course, it would just be your base times your height. But if you want a triangle, now you're wanting just half of that area. So if you draw your diagonal, you would actually take the base times the height, or length times the width, and you would take half of it. So if I want to determine the area of the different triangles, I need to look for the base and the height, and the base in this case, and don't forget to take half of it. The base would be 15. The height would be 8, not 17. 17 is what we call a slant height. I need to know where it's going to meet the base perpendicular. And that would be 8, and I want to take half of it. So 2 will divide 8 4 times, and 4 times 15 is 60 square inches. That would be the area of this triangle. Here we recognize the base and the height. So 40 multiplied by 18 divided by 2. So I'm going to take 2 will divide 18 9 times. So what's 9 times 4? It's 36, times 10 would be 360, and that would be 360 centimeters squared for the area. So base times height divided by 2. Here we recognize the height to be 12, because remember, we're looking at that highest point and downward, and so that's what the drawing represents. But here's your base of your triangle. So you are going to take 20 and multiply it by 12, divide it by 2. So I know 2 will divide 20 10 times. So what's 10 times bigger than 12? And that would be 120 square units. And then over on this one, we recognize the base is 14. I need to find my height that meets the base at a perpendicular, which would have to be this 5, not the 6, not the 12. So it would be base times height divided by 2. 2 would divide 14 7 times, so 7 times 5 is going to be the area, and that would be 35 square units. If you're looking at irregular shapes, you could draw a line here. And so now we've got a 12 by 12. So now we've got a rectangle. Plus I need to find the area of this triangle. Well, we know the height is 12, but the base is not 20. So if this length here is 12, and this is 12, but the entire base is 20, then that means that the remaining has to be 8, and we need to take half of that. So 12 times 12 would be 144. 2 will divide 12 6 times, so 6 times 8 is 48. And then we're just going to add those together. We would get 192 square units. And then here we would find this area and then this area. So this is a 5 by 20, which is 100. Take half of it, you're going to get 50 square units for the first area. And then the second one would be a 20 by 10, which would be 200 square units. So you just want to add those two together, and you would get 250 square units. Here's one where we could decompose it. So here's one method, is we could just draw a line across, and then we're going to know, okay, well that's 2, that's 4, so that has to be 4, and that has to be 2. So this area is going to be 8 square centimeters. And if this is 10 and this is 2, then this is going to be 20 square centimeters. So 20 plus 8, and we would get 28 square centimeters. All right, well, what if I looked at it as a different approach? And what if I enclose the figure and now I just want to subtract out that piece? So I would need to know the total area, and the total area would be 10 by 8, which would be the total area, which would be 80 square centimeters. And then I would need to find the area of the yellow, which would be 8 by 4, which would be 32. And so once you subtract that, you should get that's 79 and 31. So I should get 48 square centimeters. So that didn't match up my other one, so I need to look at my other one. And so this length here was 10, that was 2, so that was going to be 20 square centimeters. And then this was 2, and this was 4. So that's going to give me 8 square centimeters. So that does give me 28 square centimeters. I'm not sure what the well, I know right now, because that's not 8, because it was 10, that was 8, so that makes okay, so if I'm wanting to subtract this rectangle here, if the entire piece was 10 and this was 2, that does make 8, and then this is this entire piece is 8, and that's 2. That should really make that 6, not a 4 there. And so that 8 times 6 is 48. And so 80 take away 48 should be 32. And then this one, I'm going to have to look at that one just all together here. I wonder if there's an error on the drawing. Yeah, there's an error on the drawing there. So if this length is 8 and this is 2, then that makes this 6. And if this is 8 and this is 10, then that makes this 2. So that should be, okay, so this here would be a 2 by 6, which would be 12 square centimeters. And then this is 2 by 10, so that's 20 square centimeters. So I should get 32 square centimeters if I subdivide it. And then if I want to go with the entire area like this and overlap it, or that should be a 10 by 8, which is 80. And then this should be 8 times 6, which should be 48. And there's my 32. Sorry about that. I had an error on my drawing, and so that's no good. So you should still show that the results are the same. Okay, and if you have this one here, you could subdivide it here and here, and then you create 3 rectangles. Well, if this one is 5.5 and this one's 2.5, then that should make this one 3. And if this is 2 and this is 1, so that's 3. So that should make this one 4/10 if this entire piece is 3 4/10. So that should be 4/10, 1, 2, certainly not drawn to scale. So if we find the area of this little one, that would be 2.5 multiplied by 2, which would be 5 square centimeters. And then this one would be 5.5, because that's what this is. And then this would be 4/10 and 1. So that would be 5.5 multiplied by 1 4/10. And that will be 7 7/10 square centimeters. So this one takes care of this one. This one will take care of this one. And then this one's going to be 3 by 1, so that would be 3. So we'd be left with 3 square centimeters. So this would be 5, 7, 12, 13, 14, 15, and 7/10 centimeters squared by subdividing it. And let's look at one more. So if this one is 18, this will be 6, this will be 3, so that's 9, so that makes this have to be 9. And if this is 6, of course that is 6. We're saying this is 9, so if you want to use think about, well, that height has to be 9. And if this is 6 and this is 3, then this has to be so this has to be 9 in order to match the 18. So we could figure out the area of the rectangle, which would be 18 by 6, which would be 60 and 48, which would be 108 square centimeters. And then the triangle would be 9, because the base is 9. Yeah, so that's 6, that's 3, that's 9. So this entire base has to be 9. So 9 times 9 would be 81, but I've got to take half of it. So 40.5 centimeters squared. add those together, and you're going to get 148.5 centimeters squared, because that's what 108 and 40.5 add up to be as your irregular shapes. So that concludes Exam 2, Lesson 3 video on simplifying fractions, multiplying fractions, and area of shapes.